Today we're going to interpret the characteristics of a recursive routine in terms of context, which means a real-world situation. So you walk into an elevator in the basement of a building. Its control panel displays 0 for the floor number, which makes sense because it's the basement. As you go up, the numbers increase one by one in the display, and the elevator rises 13 feet for each floor. The graph, over here, shows the floor numbers and their heights above ground level. First, write a recursive routine that represents the height of the floors. Well, again, a recursive routine, I always need to say where to start. So start with -4. And I know this because this is the same situation we had in Learning Target 1. Otherwise, I might not be able to tell from the graph that that was a -4. Then I have to say, with a recursive routine, what to do next. So then, and we're going to use A and S just because that's what your calculator looks like when it does this. Answer plus 13. Now, what's the real world meaning of the numbers in the routine? -4 is the height of the basement because you started in the basement, and it makes sense that that might be below ground a little bit. So is the height of the basement. And I apologize, this is not terribly neat handwriting on here. And 13 is the height of each additional floor. So I'm just going to put each floor. And how are the numbers in the routine represented in the graph? -4 is on the y-axis. Remember, y's rise. It's our start value. So -4 is the start value on the y-axis. And 13 is what we're going to call the rate of change. And again, I apologize for the handwriting, is the rate of change And what I mean by rate of change is this. If I look at these points, I go up 13 every time I go, in this case, over 1. So it's also our rise over our run, which we're going to call something else later on. Now, a linear relationship, and this is not filled into your note sheet yet, it's a relationship between two variables that is characterized by a constant rate of change. So go ahead and write that down. The important part here is that there's a constant rate of change. Now, before our next class, look at this scenario. Write a recursive routine that represents the student's distance from class, explain the real-world meaning of the numbers in the routine, and tell how the numbers in the routine are represented in the graph. Thank you.